So welcome to Everyday Mathematics. Today we still on the 2023 University of Florida Integration B on the qualifying round set of problems. We're looking at problem 21, which is the indefinite integral of 3 to the power e to the power cosine of tangent of x times e to the power cosine of tangent of x times the second squared x times sine of a tangent of x. So this is an interesting problem, kind of intimidating, but at the core of it, it's a very simple problem. Here at Everyday Mathematics, what we do is we go about and around and look at interesting problems. We solve them and we share with you our version of the solutions. If you're here for the very first time and haven't subscribed to our channel, we do encourage you to consider subscribing to our channel. For here at Everyday Mathematics, we do endeavor to share with you our passion of mathematics. So without much ado, we'll move forward and solve this problem. So the first instance is to highlight the second squared of x. This is the derivative of tangent of x. And then now we can move forward and also look at the sine of a tangent of x in combination with this derivative here. So what that essentially is the derivative of the negative of cosine of the tangent of x. So that's really good. We're making progress here. We can now go ahead and really now push this negative sign out of the derivative function, and that means that now we have negative times the integral of e to the power cosine of tangent of x times e to the power cosine of tangent of x times the derivative of cosine of a tangent of x. Now, let's try to focus on the e to the power cosine of tangent of x, right? So since the derivative of e to the power x is the same as e to the power x, what that means is that the derivative of e to the power function fx is the same as e to the power function fx times the derivative of function of fx. So if we do take fx to be the function, the derivative, the function and the derivative sign here, cosine of tangent of x, then it means that our equation e to the power cosine of tangent of x times the derivative of e to the, cosine of tangent of x is the same as the derivative of e to the power cosine of tangent of x. So this is good. We're making progress. Now the next thing is looking at 3 to the power e cosine of tangent of x. That may be a little bit intimidating, but if we say u be equal to 3 to the power function of fx, function fx, then that means that we can take the natural logarithm from both sides. So we have natural logarithm of u being equal to the natural logarithm of 3 to the power fx, which means that using the rules of logarithm, where if we have a power that can be taken behind the log function, and so natural logarithm of u is the same as fx times the natural logarithm of 3. So that if we take e to the power of natural logarithm of u, we come up with u being equal to e to the power function fx times the natural logarithm of 3. So we're going to use this expression now to rework this part that is before the derivative sign. So we've converted that to e to the power e to the power cosine of tangent of x times the natural logarithm of 3. Now, if u be equal to e to the power fx times the natural logarithm of 3, that means that the derivative du dx is the same as natural logarithm of 3 e to the power fx times the natural logarithm of 3 times the derivative of fx. And that's exactly what we have here without the constant here. So what that allows us to see is that our function fx is the same as e to the power cosine of tangent of x. So we now have our expression as the integral of 1 over natural logarithm of 3 times the derivative of e to the power e cosine tangent of x times natural logarithm of 3. But we can re-express this in the form for which we were given. So instead of using e to the power, this is the same as 3 to the power e times e to the power cosine tangent of x. And so we've pulled out the constant, and so we have negative 1 over natural logarithm of 3 times the integral of the derivative of 3 to the power e cosine tangent of x. But we also know that the integral is the same as an anti-derivative. So if we have a derivative with respect to x, but also we're integrating with respect to x outside of it, that means that the function under the derivative or the differentiation remains as it is, but would obviously have to add an integration constant. So in other words, that is equal to negative 1 over natural logarithm of 3 times 3 to the power e to the power cosine tangent of x plus the integration constant. And so what that really means for us that our initial problem, this problem, the integral of 3 to the power e to the power cosine of tangent of x times e to the power cosine tangent of x times secant squared of x times sine of the tangent of x is equal to the negative of 3 to the power e to the power cosine of tangent of x over natural logarithm of 3 plus the integration constant c. So that actually is what was expected, and that's our answer with that. So without much ado, this actually is the end of our problem today. Thank you so much for hanging out with us. Until next time, have a fantastic day ahead.